Hey everyone, welcome to the channel. My name's Nader. In this video, we're actually going to build a project, which is going to be the first in this JavaScript series. This is going to put together a lot of the concepts that we've learned so far, and it's going to give you a lot of really good practice in something much larger scale than the exercises that we've been going through so far together. So if you feel that you'd like more practice with something a bit bigger and a bit more open-ended, this is a fantastic place to kind of flex your muscles and test your skills. I'll kind of go over the overview together and even give you a few tips along the way so you can have a bit of structure to the project if you like. Let's just get right into it. All right, so this is going to be a mini Blackjack simulator project. A lot of words. If you haven't played Blackjack before or you're not too familiar with Blackjack, don't worry too much about it. This is actually kind of a fake made-up version of the game anyways. But I'd like to just start with some prerequisites. So here I have listed kind of the topics that you probably should have a good handle of, or at least a kind of beginner handle of, in order to make this project a little bit easier and smoother for you to work on. So what are these topics? Variables, conditionals, loops, functions, arrays, and objects. Right? So if any of these topics kind of is a bit foreign to you or you feel you want a bit more practice, I have several videos on the channel not only explaining the concepts, but also going through some exercises so you can get some practice. As well, I have kind of a separate prerequisite here, not really necessary for you to use Visual Studio Code, but I'll be using Visual Studio Code as I have for my IDE or my text editor for my coding. Feel free to use whatever you like though if you're more comfortable with that. But most importantly, this is going to be a purely Node.js project. So that means that we're not going to be actually building anything in the browser, for example, or any HTML and CSS. This is purely to actually practice our JavaScript logic together and make sure we can understand the flow of the code and work on more complex tasks. All right. So the next kind of slide I have here is a bit of a doozy. So just a bit of a heads up warning. We're going to go through it very slowly together. All right, so this is kind of the requirements for this project. Now, I'd like you to pay close attention to this because I have changed a lot of the rules, and this is definitely not the traditional Blackjack you might be used to playing if you've played it before. So for this project, let's kind of start here with this kind of gray box in the top left. We want to be able to generate a deck of 52 cards. All right, and those are the cards from the number 2 all the way through 10, plus the face cards, Jack, Queen, and King, as well as the Ace card. Okay, and each card has to have all 4 suits, and I'll show you what the deck looks like shortly, but those are kind of the hearts and diamonds and things like that. At the start of this game, or the simulation for this game, what we're going to do is we're going to have a dealer and we're going to have a player. Okay, and each, the dealer and the player, they're both going to get dealt 2 random cards from this deck at the very start of the game. This is actually going to have the effect of reducing the amount of cards in the deck, just like you would in a real kind of card game, so that the probabilities of picking certain cards remains intact. Okay, so for example, after this initial deal, where we're giving 2 to the dealer and 2 to the player, we're actually going to have 48 cards left out of the 52 cards. All right. So once we have that initial setup out of the way, so the kind of deck of cards, as well as the initial deals for the player hand and the dealer hand, we're going to kind of go over to this orange section. And this is the kind of core game simulation loop, if you may. So this might seem a bit tricky. So let's go through it a bit slowly together. The way that this is going to work is it's effectively going to be a loop. And we're going to take turns where the player is going to go first and draw a card, followed by the dealer going right after the player and then drawing a card as well. To make this a bit simpler, I've modified a lot of the rules so that we can kind of not worry about some extra complexities. However, I'll leave those as bonuses if you're interested. So that said, in this loop of the game, what's going to happen is we're going to continue looping until either the player or the dealer gets either exactly 21 points, and I'll go through the point systems in a second, or they go over 21, right? So in traditional Blackjack, if you get 21, you win. And if you go over 21, you lose right away. Or you can kind of do these other things where you can kind of like stay and things like that, but we're not going to build that functionality right now, just to keep it simple with the logic, all right? So what's going to happen first is the player is going to be dealt a card from the deck, very similar to how we dealt 2 cards to the player and the dealer initially when we first started the program. Then what we're going to do is we're going to check if the player kind of failed either of these rules. Did they go above 21, which means they lost, or did they score exactly 21, which means that they won right away? All right. So if neither of those are true, then we continue to the dealer's turn, okay, within the same loop. And the dealer kind of goes through the same process. So the dealer is going to be dealt a random card from the deck, and we're going to do those 2 checks again. We're going to ask if the dealer went above 21, which means that the player actually wins and the dealer loses, or if the dealer gets exactly 21, and then the player is going to win and the dealer loses. And then what we do, we just repeat this loop over and over again, kind of like a simulation where it goes player, dealer, player, dealer, player, dealer, until one of them wins or loses. Okay, so it's not really a game. There's not much interactivity. However, there's definitely ample logic in here to get a lot of kind of complicated practice with JavaScript. All right. So for the points, the actual kind of cards with the numbers, so 2, 3, 4, all the way to 10, they're going to actually have the value of their actual kind of face value. So if you get a 2 or you get a 3 or you get a 4, that's how many points you get for that card. Okay, so for example, if I drew a 3 and then I drew a 4, I would have 4 plus 3, which is 7 points. All right. The Jack, the Queen, and the King, so the face cards, are each worth 10. Okay, there's no difference between the 3 of them. They're just all worth 10 points each. Now the ace is tricky. For this project, I've made it simpler for us, just so we have to worry about less kind of logic because there's already a lot to work with. So I'm just going to say that the ace is worth only 1 point. Now in traditional blackjack, this is a bit more complex where it can be worth kind of 1 or I believe 11 or something like that. And if you feel like you want the extra challenge, once you're done the rest of the project, I highly encourage you to try that out. Where you can either use an ace to get more points for an 11 or less points as a 1, depending on kind of which gets you closer to 21 without going over. All right, so for now, we'll keep it as a 1, and that's the solution that I'll be kind of coding up as well in the following video. Then I want to also do some logging in this project so that we can actually kind of see these hands and what we start with and what we end with, just so it's a bit more clear. And I'll show you kind of a demo of what that would actually look like. But effectively, we want to log both of the hands of the dealer as well as the player at the very start of the game, just so that we can see kind of who has what. Then we're going to enter this loop right here, which is this orange section, do all the simulation of dealing the cards. And then we're going to kind of, at the very end, once someone either wins or loses, we're going to log out the ending hands, who won, and then the relative scores for both the dealer and the player. Okay, so I encourage you to come back to the screen and kind of pause the video here once you're actually working through the project. But I'll just continue here with a bit more information just so it's a bit easier to understand what's happening. So for the deck, this is kind of what the deck is going to look like. We're going to have these cards, right? So 2 through 10, plus the 3 face cards, Jacks, Queen, King, as well as the ace. However, each of these cards is going to have its own suit, right? And there's 4 suits in a deck of cards: the hearts, clubs, diamonds, and spades. So in total, we're going to have these 13 cards where each has 4 suits, which is going to give us 52 cards in total. Okay. And remember that as we're kind of pulling cards out of the deck, both for the initial draw as well as the draws within the actual loop, where we're going player, dealer, we're actually reducing the amount of cards that we can draw from. So we're going to go from 52 to 50 to 48, and then 47, 46, 45, and we're going to have less and less cards to draw from, just so the probabilities remain intact. Okay. So I want to show you kind of a bit of a demo. I have some screenshots of this kind of simulation running, just with some different examples of the player losing, the player winning, and the dealer winning and losing, etc. Just so you can see an example what this might look like. Now, before I show this to you, I do want to mention that this is just one possible solution. I'll probably say this a few times in the video because it's so important. There are almost an infinite number of solutions that you could probably come up with when trying to build a project like this. I'm just going to show you kind of the way that I personally did it. All right. Is that the right way? I don't really know if you could say that's the right way. It is one of the ways, right? Is it the best way? I also can't say that if it's the best way, right? I can just say it's one of the ways that you could build it. So if you want to try this without kind of any extra hints, I'd encourage you to kind of do that. And I'll give you a point in the video where you can kind of pause and not continue if you want to take a stab at it without kind of any hints. All right. So this is what I have right here for some screenshots of what this looks like. This is 6 different screenshots of the game running. You can see that I'm using Node to run my file here, which has all of the logic for what I just mentioned earlier in the previous screens. So you can see we have kind of like the starting player hand, starting player score, starting dealer hand, starting dealer score. Then we kind of go through the game and we see who wins and who loses, and then the ending player hand score and ending dealer hand and score. And that's the same for every single one of these. It's just the hands and the scores are different for every single run because it's totally random what cards that you actually pick from a deck of 52 cards. Okay, so every run that you kind of simulate this game or run this game, you should get a different result because it should be randomly drawing cards from a deck just like you would in real life. All right. So you might notice a couple of interesting things here. Again, not necessarily the way you have to do it. I was a bit lazy, I guess, when showing this because I wanted to keep it as simple as possible. You can see I'm just logging out arrays of objects where each object is a card. You don't have to do it that way. That's just one way to do it. And I'll give you some tips on how that might make things easier in a future screen. Okay. Now, I want to kind of go through some advice because whenever you start a project like this, there's always kind of a tendency to feel this like analysis paralysis or sense of overwhelming, just so much happening, right? And that is extremely common. In fact, if you don't feel that, that's probably a minority, right? I still feel that to this day with all sorts of kind of fanciful projects, and that's a good thing, right? You never want to get too complacent with where you are. You always want to make sure that you put your best foot forward and try your best with every single project. And if you make mistakes, that's totally okay. So just some advice for this project and frankly, any project that you work in JavaScript. So I'll just go through these and kind of give a bit of explanation for them. Anticipate that you're going to get stuck. Okay. I know that when you start a project like this, it might seem like, okay, that might not be too complicated. I can kind of build this thing. And then inevitably there might be some kind of bug or some kind of thing that you didn't really account for, and it breaks your kind of program or crashes, right? And you will get stuck, right? I can't imagine someone who would just code this from start to finish unless they have a lot of experience with development. And even then, I anticipate there to be kind of issues. Even when I was building this solution for the first time, there were some issues that I ran with and I forgot certain cases to deal with, all right? So the most important thing is that when you're getting stuck, don't treat it as a failure, okay? Super, super important. You want to embrace kind of the getting stuck, as crazy as that sounds, and you want to realize that it really is part of the process and part of learning, all right? It's never the case that you're going to work on these projects and just kind of breeze through them from start to finish, and it doesn't work that way in real life either when you're working on projects on teams, okay? There's always going to be hiccups along the way. Embrace it, even anticipate it, and then just work through it and continue learning and embrace that feeling of stuckness. Eventually, you will get over it 100% of the time. All right. Now, that said, if you get stuck for too long, right? And this is different per person, right? Some people, this might be 10 minutes, 15 minutes, it's maybe half an hour or an hour, right? Generally, I wouldn't say you should want to be stuck for an hour or longer. That's quite a long time. I would probably say kind of on the lower end. You definitely want to look for ways to not get frustrated, right? There are many strategies you can use here. You can take a break. You can go try another section of the program that might not be related, and then come back to the place that you got stuck later with some extra insight or kind of a fresh mind and solve it. I can't count the amount of times where I've been working on something, for example, late at night, and I just can't get through it. And it feels like, oh my gosh, like I'm going to be, there's no way I can get over this problem. It's impossible. It feels almost impossible, right? And I inevitably end up going to sleep, and then the next morning I take another stab at it and I end up solving it very quickly. Okay, now that doesn't always happen, but really, really makes a big difference. Don't just hammer your head against something endlessly and get frustrated. That's not the best strategy. Take a break or look at another part of the program, or even just do some Googling, which is the next one. So that said, Google, or frankly any search engine, is definitely your best friend. I forget who said this to me, but I think it's a pretty good kind of quote. The best developers in the world definitely aren't the ones who memorize everything possible within a language or within computer science, for example, right? They're the ones who memorize the minimum needed in order to do what they need to do efficiently, and then know what to look up on search engines when they need it. Because today, with the modern internet and fantastical search engines like Google, we really don't need to memorize things as much. That said, we need to know the concepts behind things so that we know what to look up. However, trying to memorize syntax or functions or methods and all these kinds of things, or even ways to do simple problems like maybe generating a random number or something like that, you don't have to memorize that stuff, right? I definitely don't memorize that stuff. I try to fit into my brain the minimum needed to actually get stuff done, and I Google pretty much everything else. All right. Now, that said, when you're Googling, be careful not to just copy and paste code off the internet. There are very many sites out there that will have different solutions, for example, how to create a deck of cards, how to create random numbers, how to deal a card, etc. And it's very tempting to just kind of copy and paste that code, especially if it's in the language that you're interested in, for example, JavaScript in this case. All right. I would highly encourage you to never do this. All right. The reason is that, kind of like in school, if you remember, teachers would always say to write stuff down on paper, how it helps with your kind of muscle memory and kind of puts things in your memory banks per se, very similar to how maybe we might sleep and recall things much better. It works the same way with coding. If you're not flexing your muscles and actually typing out the letters yourself, even if you're just typing out exactly what you see in something like Stack Overflow or some other thread that you're getting help from, you will actually learn much less. And you'll have less understanding of your code and how it works. And everything will just become more brittle, and it'll lead to problems in the future. So definitely get in the habit now of not copying and pasting code. And if you do see code that you do need, just write it out yourself while looking at the actual code snippet that you have on a separate screen or in a separate tab somewhere. Okay. And make sure as well that you understand what you're copying. Okay. I can't count the number of times where people I've worked with have copied code, and it's you kind of go through them and they have a bug, and you're wondering, well, what's this bit of code doing, and what's happening over here? How did you get this solution? And then they usually will say like, oh, I got this from this article or Stack Overflow or blog post or whatever it happens to be, right? And if you're not understanding every single line that you're copying, you're actually doing yourself a huge disservice. Okay. And I know that this seems kind of overly pedantic or harsh. However, I promise you in the long run that it will help you probably more than most of his other advice. Okay. Trying to understand what you're writing and where you're copying and what it's doing, even if you're just reading it and then typing it out yourself again as a copy, is fundamentally important. Okay. So next, this project and future projects are going to have a whole bunch of steps. There are many, many parts to these projects, and the same is true in real life as well. It's usually not as simple as just write a function to like add two numbers or do this little thing. Usually you want to create a more sophisticated kind of program, and you might be working on something like you want to create a form that submits information to a database, and then you want to make sure that it's the correct information for an email or a password or something like that. Right? So usually there's more open-ended questions basically that you're going to need to answer in real life as well as in future projects. And the most important thing to keep in mind is that you're not probably going to know the answer or how you're going to actually approach the entire solution from the start. Okay. However, if you actually break down that solution into smaller subproblems, what ends up happening is that you can actually end up solving those subproblems, right? And if you get stuck on one, you can maybe move to another one and come back to it later. And what you'll quickly realize is that as you're working on those subproblems, before you know it, actually, you'll end up actually solving the entire project or the entire thing that you're working on, right? And you'll kind of see a much clearer path to actually where you're trying to get to as you're working on the kind of smaller functions that are going to be added up into a bigger kind of project. And probably most importantly, I know I said this for most of these, but you want to have fun, right? Make sure you're having fun with this project and with pretty much any code that you're working on. If you're feeling like it's a chore or frustrated or annoyed, maybe you should take a break and come back to it later, right? It's not always necessary that you have fun. There's definitely going to be times where you're going to be looking at something and it's kind of annoying or boring. However, generally, if you have fun with something that you're working on, regardless if it's coding or anything else that you're learning, it's much easier to actually work through that, especially when it comes to getting frustrated or getting stuck. All right, so don't forget to have fun as much as you can as you're working through projects. Okay, so that said, I promised I'd give you kind of a place to pause the video if you don't want any kind of hints or tips or strategies. What I'm going to go to next is kind of how I built the project. I'll go through it kind of at a higher level, as well as a bit of a code snippet and structure as how you can kind of build out this project if you feel a bit overwhelmed and you kind of want a place to start. If you don't want to see that and you want to build it yourself, definitely pause the video here and go back to see the requirements and kind of build it out yourself. And then maybe you can see this part after to compare your solution to mine. All right, so that said, let's take a look. So I have some tips here for how we can actually approach this problem. Now, again, I want to preface this by saying that this is just my solution, right? I know I've said that a couple of times, but it's really, really important to realize this. There is by no means only one or two or three solutions to this project or problem. It's almost always the case that there's multiple ways to solve a problem. This is just the way that I approached it. I've actually solved this in many different ways in many different languages, and each way I do it slightly different, right? So I just wanted to come up with a way that might be a bit easier with some new techniques so that you can actually see some new ways of programming so that we can use them in the future as well together. So I mix and match some different techniques. Okay, so that said, the first tip, make sure you understand the requirements. I know this seems kind of strange or redundant, but I can't count the number of times where people will read the instructions and build something that doesn't match the actual original requirements. Okay, so make sure you really understand what you're building. Maybe even run through it a few times, go back to the demo code I showed, maybe draw it out on paper, however it's easiest for you to actually make sure you understand how this project is going to work. Make sure you go through that flow a few times so you actually know what you're building. If you just jump straight to the code without actually understanding what it is you're building, you are probably going to make it much harder for yourself and potentially increase the amount of time you're going to get stuck, as well as the amount of bugs that you might have. So definitely spend that time up front to actually make sure you understand it. I think there's a famous quote, I forget who it was, but you want to sharpen that axe per se before you start chopping away at the tree, right? So that said, how can you actually go about building this project? So I kind of want to put this in a series of stages. One thing you might want to ask is, how can you actually model a card? Okay, we know that a card has a value and a suit, right? So one strategy you might be able to use is to use objects. And this is kind of what you saw in the demo that I showed you earlier. I have an object with kind of two sets of properties. A card property, which is a string, which is like king or two or ace. And then a suit, which is the four different suits: hearts, diamonds, clubs, and spades. Okay, so I actually will have each card be this object, which is going to represent that card that is being drawn or putting into a deck. All right. The next thing that you want to do is try to figure out how to generate a deck, right? And this comes back down to breaking down this into sub-problems so that you're not trying to do everything at once, and you can kind of mix and match these different functions that you're going to end up building or move to different ones and come back to them later. So then we can probably build a function that creates a deck of cards, okay? So the purpose of this function is literally to only build up that deck of 52 cards, which in this case, if we're modeling it this way with this object, is going to be an array of objects, in this case 52 objects, where each object kind of looks something like this. Okay, so we're going to end up having like the 2 of diamonds, 2 of hearts, 2 of spades, etc., all the way up to like king or ace of diamonds, ace of clubs, ace of spades, right? So there's no duplicate cards in the deck, but there is the 13 different values, each with the 4 suits. So deck in this case would be that array of card objects. All right. Then what I would probably say is maybe you could build a function that helps you draw a single card from the deck that you just generated. Okay, so this function, for example, if you were to call it something like draw a card, it might take the deck as an argument. Okay, and what it would do is it would generate a random index so that it could pull out of that card, or out of that deck, sorry, a random card, and then permanently remove it from the deck so it can't be drawn in the future, and then return back that card so that we can store it here in another variable, for example. Okay, so if I did this, card might be, for example, this card right here, King of Hearts. And then now King of Hearts is forever removed from my deck of cards. Okay. Then what you might want to do is create a function that calculates a score for you given a hand. Now, a hand is basically the set of cards that the player or the dealer might have. So this would be an array of card objects, in this case, if you were to build it this way, where we could calculate the score given the points that we saw earlier. So just to kind of recap the points, these are the points right here. 2 through 10 are the actual values, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, and King are all worth 10 each, and aces are worth 1 each. So if you got an array of cards, for example, with 2 kings, right, maybe King of Hearts and King of Diamonds, this score would probably be 20. Okay, so if we were to give that array of objects to this function, then we would get back the actual number for the score. Now, you don't have to do it this way. This is just one way that you could do it. I really have to emphasize that there are many, many ways you can do this, and you don't even technically need to really use functions. However, I highly would recommend that you do to get more practice and to modularize the code. Now, finally, the kind of core game loop per se, or the simulation loop. The way that I did it was I effectively created an infinite while loop, like you see right here, where we kind of follow those steps, right? And those steps are right here, right? These steps right here, these 6 steps. So in that loop, we want to deal a card to the player. Then we want to kind of ask the questions using some conditionals. Did the player bust, which means that they go over 21? If they did, then the player loses and the dealer wins, right? We can break out of the loop. Did the player get exactly 21? If they did, well, they win right away, right? And the dealer loses. If neither of those are true, then we go to the dealer, right? Because then we're below 21 for the player. Then we do the same steps for the dealer as well. We have the dealer dealt a card, very similar to the player. Then we ask if the dealer bust, did they go over 21? Or did the dealer hit exactly 21? And then in which case they would win. Right? And if neither of those are true, then we kind of loop back around and we keep dealing cards until someone either wins or loses, and we can kind of exit this loop by breaking out of it. Now, again, one way that this is done, right? This can be done in many other ways. If this is a bit complicated, or you came up with other methods or other functions or no functions even to build this, that's totally valid. I just want to show it to you this way so that you can see how this might be done using functions as well as a loop like this, in this case, without using a function. So just to show you kind of a bit of the code. So you can see here that I basically built it out. So this is actually the code that I kind of ran earlier, blackjack.js. And I hid all of the function bodies as well as the loop body right here, right? But what you can see is I have this generate deck function, right? I have this draw card function and then this check score function, right? And I'm generating the deck to start right here. I'm initializing the player hand and the dealer hand to be empty arrays, which in the future we're going to be adding card objects to as we start dealing them or drawing them, sorry, out of the deck using our draw card. We are going to, in this case, I kind of did this all in one line. I could probably have separated this out. I just wanted to fit it onto one screen. I'm going to push onto each of these array, whatever I get from drawing a random card from the deck. And this function is actually going to remove that card from the deck so it can't be drawn in the future as well. Okay, so we go from 52 cards right here to 48 cards after we've dealt these 4 cards. Then I'm going to do this logging so that we can see what gets what's in the hand as well as the score for that hand at the start, right? And then we kind of have the core game loop down here where all the logic is contained for dealing to the player, checking the scores, dealing to the dealer, and then checking the scores until one wins or loses. And at the very end, we see the actual logs again one more time for what the dealer and player had, as well as their scores at the very end of the game. Okay. So that's pretty much it for this video. What we're going to do in the next video is actually see the code for this and write it out ourselves together. However, I encourage you to try this out, whether using this method or your own method, and really kind of trying to learn some new functions, Googling a bunch, coming back, taking a break, writing these functions out yourself. It will really, really go a long way. This will take some time. Anticipate that it will take some time, and anticipate all those errors that are going to happen along the way. But definitely test your code as you go, right? Like if you're doing it this way, you can generate a deck and log it out. Make sure that that's actually working as you would expect, and you're actually getting that deck of cards. Same with drawing a card. Make sure that actually works, right? As you would expect, log it out before you try to do too many things at once. Same with checking a score, right? If you do it this way, pass this function a hand and see if it's really calculating the score properly, right? And do it many, many times to make sure that it works in all this crazy cases with like aces and kings and things like that. All right. So give that your best shot. If you do get stuck, definitely put a message in the comments and I'll try my best to kind of help out or give you any tips. If you like this video, definitely subscribe to the channel and like the video on the channel. What we're going to do in the next video, as I mentioned, is we're going to actually go over kind of my solution, which is this solution right here. And we're actually going to code it out together from scratch, as well as kind of go through kind of mentally how I actually prepared the logic one step at a time, as well as all the Googling needed to actually get this to work. I can't wait to get to that video. I'll see you there.